Tectonic tsunamis. These are the most common tsunamis and begin with powerful underwater earthquakes that shift the seafloor. When a large section of the Earth's crust suddenly moves, it pushes an enormous volume of water upward, creating waves that spread across the ocean. In deep water, these waves travel quickly and remain relatively low, often unnoticed by ships. As they approach shallow coastal areas, they slow down and grow dramatically in height, becoming destructive walls of water. The 2004 Indian Ocean tsunami is a clear example, where a massive earthquake triggered waves that affected multiple countries and caused widespread devastation. These tsunamis matter because they can travel vast distances and strike coastlines with little warning, especially when communities are close to the epicenter. Volcanic tsunamis. These tsunamis are caused by volcanic activity that suddenly displaces large amounts of water. Explosive eruptions, collapsing crater walls, or lava rapidly entering the sea can all trigger waves. In some cases, entire sections of a volcanic island may collapse into the ocean, pushing water outward with great force. The eruption of Krakatoa in 1883 is a well-known example, where massive explosions and collapsing land generated deadly tsunamis. These waves devastated nearby coastal regions and caused significant loss of life. Volcanic tsunamis are less frequent than tectonic ones, but they can be highly destructive in areas near active volcanoes. They matter because they may occur without typical earthquake warning signs, making them harder to predict and more dangerous for nearby populations. Landslide tsunamis. These occur when large amounts of rock, soil, or debris suddenly fall into a body of water, displacing it and generating waves. This can happen along coastal cliffs, underwater slopes, or even within lakes. The force of the falling material pushes water outward, creating waves that can be extremely high near the source. Unlike tectonic tsunamis, these are usually more localized but can be very intense in a small area. The 1958 Lituya Bay event in Alaska is a famous example, where a massive landslide triggered a wave that reached extraordinary heights. Landslide tsunamis matter because they can occur suddenly with little warning and can produce very steep, fast-moving waves that impact nearby shores almost immediately. Submarine landslide tsunamis. These tsunamis are caused by landslides that occur entirely beneath the ocean surface. Large amounts of sediment or rock shift along the seafloor, displacing water and creating waves that travel toward coastlines. Because these events happen underwater, they are harder to detect and may not be immediately noticed. They can be triggered by earthquakes or by the gradual buildup of unstable materials on the ocean floor. An example is the ancient Storega slide, which occurred thousands of years ago and generated significant waves in the North Atlantic. These tsunamis matter because they reveal hidden dangers beneath the ocean and can still produce damaging waves without clear warning signs on the surface. Meteor impact tsunamis. These rare tsunamis occur when a large object from space strikes the ocean with tremendous force. The impact instantly displaces massive volumes of water, creating waves that can spread across entire ocean basins. Although no recent large-scale events have been recorded, scientists study past impacts to understand their potential effects. The Chicxulub impact, which is linked to the extinction of the dinosaurs, likely generated enormous tsunamis millions of years ago. These tsunamis matter because of their extreme scale and the global impact they could have if such an event were to happen again, affecting coastlines far from the point of impact. Glacial tsunamis. These occur when large pieces of ice break off glaciers and fall into nearby water, displacing it and creating waves. This process, known as calving, is common in regions with glaciers that extend into oceans or lakes. When large chunks of ice collapse suddenly, they can generate waves that are dangerous to nearby boats and coastal areas. In places like Greenland, such events have been observed more frequently as glaciers continue to melt. While glacial tsunamis are usually smaller than ocean-wide events, they can still be powerful in confined spaces such as fjords. They matter because they are linked to changing environmental conditions and can pose sudden local risks. Local tsunamis. These tsunamis affect areas close to where they originate and often arrive within minutes. They are usually caused by nearby earthquakes, landslides, or volcanic activity. Because of the short distance they travel, there is very little time for warning or evacuation. People in affected areas may feel strong ground shaking or notice the sea rapidly receding before the waves arrive. The 2011 tsunami in Japan is an example where coastal regions were quickly impacted after a major earthquake. Local tsunamis matter because their speed makes them especially dangerous, requiring immediate awareness and rapid response to reduce loss of life. Distant tsunamis. These tsunamis travel across entire oceans from their source and can take several hours to reach distant coastlines. Despite the long journey, they can still carry enough energy to cause flooding and damage when they arrive. Early warning systems play a key role in tracking these waves and providing time for evacuation. The 1960 Chile earthquake produced a tsunami that reached Japan many hours later, demonstrating how far these waves can travel. Distant tsunamis matter because they show how interconnected the world's oceans are and how a single event can affect regions far away. Mega tsunamis. These are extremely large and rare waves caused by massive and sudden displacement of water, often from huge landslides or volcanic collapses. Unlike typical tsunamis, they can reach extraordinary heights near their source, sometimes towering hundreds of meters above the water. The Lituya Bay event is often cited as an example, where a massive wave was generated by a landslide. Although such events are uncommon, their impact can be devastating in local areas. Mega tsunamis matter because they represent the most extreme form of wave activity, capable of causing intense destruction in a very short time. The Earth is more powerful than we think. Subscribe for more content like this.